like, share, subscribe.
Hey y'all, welcome back. Tonight's homework covers logarithms, and we have several problems here that will be similar to those that you'll see on the CLEP college algebra exam. We covered problems similar to all of these in class, so if you want a more detailed explanation on any of these, please go back to the notes video where I go a little bit more in detail. On this homework video, I'm just really going to be working out and narrating the steps as I go. So as you can see, like, each section here has 3 or 4 problems that are very similar to the one that's on the official study guide. I really just want to make sure that you know how to solve these kind of problems, because odds are there's going to be a few of these, like a few problems like this on the actual test. So let's start with this first section where we're solving for x. And for all of these problems, these first 4 problems, we're going to be basically doing the same couple of steps here. So for number 1, we want to use the inverse property to rewrite this as an exponential equation. And we'll do that for all of these, but for number 1 specifically, we get x plus 2 equals 4 cubed. So all we did was just invert this equation. Effectively, we just raised both sides as powers of 4. But this is kind of a quick way to get there. So it's whatever's inside here equals the base raised to the exponent of 3. Remember that the logarithm is an exponent. So that's your little clue here. Whatever the logarithm equals, that's your exponent. The base is the base in both cases. And when we invert this, originally the argument, or our input, which was x plus 2, is now our output. So this is going to be our equation. From here, we're just going to solve it by simplifying that 4 cubed first. So 4 cubed, that's 4 times 4 is 16, times 4 is 64. And then lastly, we can use the subtraction property of equality to subtract 2 on both sides, and we end up with x equals 62. So all these problems are going to be basically work the same way. You can see they're not that hard. You just have to know how to correctly rewrite these logarithms as exponential equations. If you can do that, that's, I think, kind of the hardest part, is making sure you got everything in the right place here. So that's what we're going to do a few of these that are very similar, just so you can kind of get the hang of it. This next one, the original argument or input was x plus 3, and the base is 2, the exponent is 3. So see how it's set up basically exactly like number 1. But yeah, so anyway, 2 cubed is going to be 8, so we can rewrite this as x plus 3 equals 8. Then we can subtract 3 on both sides, and we end up with x equals 5. So yeah, that's our solution for number 2. For number 3, same basic idea here. 4 will be basically the same too. We get x plus 5 equals 3 cubed. This is going to be 3 times 3 times 3. So you do get a scientific calculator, but you could probably do this just in your head. At 3 times 3 would be 9, and then if you multiply one more 3, you get 27. Then I want to subtract 5 from both sides, so I get x equals 22, and that's our solution for number 3. Number 4 is just really the 4th version of this exact same problem. So we get x plus 6 equals 4 to the first power. 4 to the first power is just 4, so we get x plus 6 equals 4. And then if we subtract 6 from both sides, we get x equals negative 2. Now, I know we've talked before about being wary of negative solutions here. It's not so much that the value of x can be negative. That doesn't really matter. What matters is if you plug this back into the logarithm and the input to this logarithm becomes negative. That's when we start having problems, because that's going to be outside of the domain of any logarithmic function. You can't plug a negative number in here. You just can't. We can go into a lot more detail, but let's just say that for now you cannot take a logarithm of a negative number. So this is actually a safe answer here, because if when I plug in negative 2 here, I get negative 2 plus 6, which would be 4, and that's positive, so I don't have any issues doing log base 4 of 4. That does equal 1. But like, let's say we work this out and I got like negative 8 or something like that, where if I plug that in here, negative 8 plus 6 would be negative 2, then we have issues. I can't do log base 4 of negative 2. That would be incorrect. It would be undefined. Yeah, the logarithm's domain is from 0 exclusive to infinity. So any negative numbers just are not going to apply here. But it is okay for x to be negative 2 as long as once you plug it in, what's inside parentheses is positive. So I just want to take a moment to kind of talk about that, make sure you're not confused on why I'm accepting this negative solution. So those first 4 problems were really just all variations on the first problem we did in class. Let's look at this next set of problems. We also worked out ones very similar to these, and we'll work these out the same way. So basically what we're going to do here is we're going to simplify each statement, and each step I'll try to only do one thing in each step here. So for this first one, we've got log base 4. Let me try to rewrite that, log base 4 of, and what I'm going to do here is I'm going to rewrite this as 64 to the 1/2 power. Okay, whenever you take the square root of something, it is equivalent to raising it to the 1/2 power. And the reason why I want to rewrite that is so that I can apply the power property and simplify this a little easier. So this next one I have log base 2 of root 2, which would be equivalent to log base 2 of 2 to the 1/2. So again, anything that has a square root on it, we're going to rewrite that as a 1/2 power. And we'll do that for all of these, actually. Okay, it just makes the whole problem go a little easier when we do that. Okay, so now we're going to apply that power property and bring that exponent down to be a coefficient. Okay, so I'm going to move this 1/2 to be over here. Well, I'll try at least. There we go. And the same thing goes for this other 1/2. I'm just using the, again, if you want to look it up, it's called the power property. All right, now I need to actually evaluate these logarithms. Okay, so I'll just do it one at a time here. So I have 1/2 times, so log base 4 of 64. The question here is 4 to what power is 64? Well, 4 to the first power is 4. 4 squared is 16, and 4 cubed is 64. So since 4 cubed is 64, that means this logarithm, which is the exponent, would be 3. So 1/2 times 3 minus 1/2 times, to evaluate this logarithm, we have 2 to some power equals 2. And this would be 2 to the first power equals 2. So log base 2 of 2 is 1. And really, any logarithm is going to equal 1 when the base and the argument are the same. And you could use that same logic to deduce that. Okay, so here what we really have is just 3/2 minus 1/2, which would be 2/2, and so it just equals 1. Number 6 will be worked basically the same way. So I'm going to at least copy this first statement and just replace the numbers with what they should be. So here we've got log base 2 of root 2, so that's going to be 2 to the 1/2 power. And on this next one we've got log base 4. Actually, these are the exact same. These are the exact same numbers as what was on the last one. So hopefully you can kind of see how this is going to work out just by looking at the last problem. But yeah, we want to do the exact same steps we did before. We want to use that power property and rewrite this exponent of 1/2 to be a coefficient of the logarithm, and we'll do that over here too with the log base 4. And we already discussed what these logarithms are going to equal, so I'll kind of go through that a little faster this time. We know that log base 2 of 2 is 1. We talked about that just a minute ago, because 2 to the first power is 2. So it's going to be times 1. Minus 1/2 times, and we talked about this one also, log base 4 of 64 is going to be 3, because 4 cubed is 64. This is going to leave us with 1/2 minus 3/2. Whoa. 1/2 minus 3/2. And 1 minus 3 is -2. So this would be like -2 over 2, which reduces to -1. Number 7. Another similar problem here, although at least we have some different numbers to work with, so that's kind of nice. We have log base 2 of the square root of 8, which would be 8 to the 1/2 power. And then we've got log base 3 of root 3. So this is another case where we have 3 to the 1/2 power. So we're going to use our power property here and rewrite this as 1/2 times log base 2 of 8, and Same thing over here with this next logarithm. We're going to move that exponent of 1/2. We delete that, bring it out to the front, and now this is what we've got. So now we need to evaluate each of the logarithms, and I'm not going to give you any numbers that are like just huge or anything like that. So you should be able to do this without a calculator. Log base 2 of 8 is 3 because 2 cubed equals 8. And then 3 to the first power is 3, so this just equals 1. And we get an answer, actually it's going to be very similar to the last one too. Okay, so we get 3/2 minus 1/2. And we actually get the same answer as number 5, we get 1. Okay, on this last one, we've got, once again, very similar problem, and hopefully you guys are catching on to the pattern here. We've got log base 5 of 125 to the 1/2 power. Again, square root just means raised to the 1/2 power, minus log base 4 of root 64. Okay, let's apply the power property one more time here and bring those 1/2 down to be coefficients. And now we can evaluate those individual logarithms. So we have 1/2 times log base 5 of 125. Well, 5 to the first is 5, 5 squared is 25, and then 5 cubed is 125. So since 5 cubed is 125, log base 5 of 125 just equals 3. Minus 1/2 times, and then we have log base 4 of 64. Again, 4 cubed is 64. We've already kind of gone over that a few times now. So that's just going to be times 3, because 4 cubed is 64. And here we have 3/2 minus 3/2, so our answer here is just actually 0. That means that these two logarithms have the same value. They both are 3/2. So you subtract them, you get 0. All right, let's move on to the next section here. It says solve for x, and so just kind of glancing at each of these problems, notice how the x is the base. So we're going to approach these kind of similar to how we did this first section where we rewrite the logarithm as an exponential equation. It's just that our unknown is going to be part of the base. So here, log base x of 3 equals 2. I'm going to rewrite this as an exponential equation. The base is x, the exponent is 2, and the power is 3. So we get x squared equals 3. And you'll set up 10 and 11 basically the same way. Then we're going to take the square root of both sides. And normally we would get x equals plus or minus the square root of 3. Plus or minus the square root of 3 here. However, we've talked about this about logarithms before. Your base has to be positive in order for it to be a true logarithm. Same thing goes with exponential functions. You can't have an exponential function with a negative base. You get all sorts of weird behavior. That isn't to say that you can't write a function that is like something like -2 to the power of x. It's just not considered exponential. And so since a logarithm is the inverse of an exponential function, it needs an exponential function to exist before it can exist. So log base x, this x cannot be negative. Okay, so we're going to disregard the negative solution here as an extraneous solution and only keep the positive root 3. So our answer is just positive root 3. Number 10 will be set up similarly, and we can have basically the same discussion here about why x can't be negative. But our setup here is x squared equals 7, and then you just take the square root of both sides. I'm not going to reiterate what I said a minute ago about why this is just going to be positive root 7. Hopefully that kind of made sense to you, but if you skip straight to this problem and are wondering about that, just rewind about a minute or so, and I talked about that back in problem number 9. Number 11, here's another problem that's set up basically the same way. We're going to have x squared equals 11, take the square root of both sides, and we get the square root of 11. And one last time, you do, when you're solving, technically get plus or minus the square root of 11, but since we cannot have a negative base for the logarithm, we just throw that one away, chalk it up to being an extraneous solution because of that restriction to what the base could be, and we're just going to keep the positive one. All right, yeah, so that's 9, 10, and 11. Number 12 and 13 really look like they're logarithmic problems, and I guess in a way they are sort of, but really you don't need to know much about logarithms to get this right. Okay, it says find f of 0 for each of the following, and so basically what we're going to do is we're going to take that 0, let's see if I can mark this up a little bit. It's not letting me for some reason, freehand maybe. There we go. We're going to take this 0 and we're going to plug it in everywhere where we see x, and there's a few instances here. And so to get this one right, you really want to use a calculator. I mean, you don't have to, but I just think you're probably better off plugging in all these with 0, just kind of throwing everything into the calculator at once. I'm going to work it out step by step here, but just know that you really can get away with just using the calculator on this one. Log base 8 of 8 is just going to be 1 because 8 to the first power is 1. And then we have plus 7 to the 0. I'll simplify that on the next step. Plus 0 minus 3 times 0 minus 1. Now anything to the 0th power, other than 0 of course, is going to be 1. So 7 to the 0 is 1. 0 minus 3 is negative 3, and 0 minus 1 is negative 1. Negative 3 times negative 1 is positive 3. So now we got 1 plus 1 plus 3. So that's 2 plus 3. That's going to be 5. So f of 0 is 5 for number 12. So yeah, really we're just taking the 0 and just plugging it into all the x's and then evaluating. So 13 is going to work out basically the same way here. We got a lot of repetition going on in this homework, so hopefully by the end of this you'll know how to work these 5 problems. Log base 9 of 9 is going to be 1 for the same reason log base 8 was 8. Anytime the base and the argument are the same value, that logarithm always equals 1, because when you raise a base to the first power, it doesn't change value. So that's why when these two are the same, you always get 1. Plus 11 to the 0th power plus 0 minus 3 times 0 minus 2. Okay, so we got 1 plus 11 to the 0, that's just going to be 1. 0 minus 3 is going to be negative 3, and 0 minus 2 is going to be negative 2. So this kind of works out very similar to number 12 here. We got 1 plus 3 times 2 is 6. They're both negative, so our result's positive 6. 6 plus 1 is going to be 8. And that takes us to our last section here. Number 14 through 16. It says solve for x and then write x as a base 10 logarithm. So not only do we have to isolate x, but then we have to use the change of base formula to use the logarithm they're asking for. So let's start by just rewriting all these as logarithms. So I'm going to I guess I'll work all 3 of these at the same time since they're all basically the same. So let's start by writing this as a logarithm. We'll have x equals, x is the exponent, remember that's what the logarithm equals, log base, and then the base is the same in both cases, so log base 2 of 30. Alright, so I'm going to come back for my final answer, but it's going to be based on this statement. Okay, for number 15, I've got x equals log base 5 of 40. And for 16, I get log base 7. Oops. Log base 7 of 25. Now, to write this as a base 10 logarithm, we need to use the change of base formula. So maybe I'll make a little note to the side here. Change of base formula. So basically what that means is you could change the base to anything you want. I'm just going to say use the change of base formula. You can change the base to be whatever you want, but the way you have to write it is as a fraction. And the argument of the numerator, so let's say I want log base 10, which is what this is asking for. If I want log base 10, I would have log base 10 of 30, so whatever is the original argument is going to go in the numerator. and then whatever was the original base will go in the denominator. So we'll have log base 10 of 2 in the denominator, and then we're essentially done. All right, so this format is basically how all these are going to work out. This is kind of an unconventional way to write this, to be honest with you. This base of 10, usually you do not see 10 written as the base. It's kind of like when you write x, you don't write like a coefficient or exponent of 1. It's just sort of implied. Usually when you have base 10, you just write log and you don't write the base 10. In other words, typically if we were to write this as a base 10 logarithm, we would just say log 30 divided by log 2. These two statements mean exactly the same thing, and literally the only reason why I'm even writing it like this, or or boxing this as my answer, is because this is how the expression looks on the CLEP study guide. Now, I'd be interested to find out is if on the actual test itself, do they write base 10 here? I don't know, but on the official College Board study guide, they put this here, and so I'm inclined to believe that's how it's going to look on the actual exam. So I'm going to stick with that, even though my better judgment says, hey, we should just write this without the 10. This is how you usually see common logarithms written. So, these are two equivalent, and I guess it's good to know that these are both mean the same thing. When you don't see the base, it's implied to be 10. But again, for some reason on the study guide, they do have the base 10 written there. I don't know why. We saw that up here on this problem too, not on 12 or 13, but on the one we went over in class had that base 10 there too, and that was on there. So this is definitely like not a slip up on their part in terms of like, oops, like we didn't mean to put the 10 there. I think it's intentional, pardon the pun there, but yeah, definitely think it's intentional, although it is curious that they would not just go ahead and write it without the 10. I can't tell you why that is. That might be worth looking into at some point. But yeah, so this is going to be how the answer would look on at least the study guide. I'm assuming the test is going to be the same way. All right, number 15, you can kind of see how this is going to work. Log base 10 of 40 over log base 10 of 5. Again, this is going to be how your answer choice looks, although it is good to know that if you don't see that base 10, then your answer will look like this, and it'll be equivalent. Like these should be the exact same thing. Usually for these common logs, we just don't write the base 10. Still a little perplexed as why, but I guess I'll just stop worrying about it so much. Number 16, we should have log base 10 of 25 over log base 10 of 7, and that's about as far as we can go there. I'm going to write my preferred answer down here, even though it, I guess, is not the College Board's preferred answer, but I like it better, so I'm just going to throw it in here. I'm not going to box it because I know that, I don't want to throw you off and think that if you see something with a base 10 that it's wrong. It's not wrong necessarily, it's just redundant because of this convention. So at any rate, that's going to be your answer for number 16, and I think that about wraps it up for tonight's homework video. So as always, please let me know if you have any questions over any of these problems. I'm happy to help you out. But other than that, y'all, thanks for watching and have a great day.